Alia hasn't said anything. She doesn't like saying anything. What's Captain Levy? Who's Captain Levy? Linnell? Who's Captain Levy? Numan. From Anime IG. Which anime? Am I being referred to as Captain Levy or Bilal? Sir Bilal. Lionel Fangs. Oh, I do. I'm watching Attack on Titan. Who's? Let me Google it, I guess. That'll be faster. I don't remember the names because there are too many people. Lionel Levy? No, it's Captain Levy. I was going with. Who's Captain Levy? Have you guys seen Full Metal Alchemist? That guy? That has to be me. Lionel, are you calling me Captain Levy? I recommend everyone to watch Full Metal Alchemist. I think it's pretty good. Avatar, the OG. That's pretty good. Pretty good. Pretty good. Yeah. Bungo Stray Dogs? Bungo? I don't know. I don't know. I want to watch a good anime, Vasa. I should be starting class, but here we are talking about anime. Bungo Dogs. Bungo Dogs. Okay. Looks pretty cool. Gangsta-y. I think I'll save this. I'll keep it open. YouTube, it's Levi. It's Levi. Captain Levi. Is it Levi? Okay. Rida, welcome. Okay. Shall we start? Shall we continue? I think you guys were doing some things last time around. So I did follow that class. I have an idea what you guys did. ठीक है. Oh, a person named Captain Levi was in the class. Demon Slayer is a good one. Demon Slayer? I don't know. Black Clover? Rings a bell. Rings a bell. I like how anime has become mainstream. When I was your age, anime was like, weird people would watch it. But I'm glad anime is now mainstream. Attack on AOA? Oh, I thought AOA was some anime for a second. And I'm like, oh, salam alaikum. Yeah. Hi, Arisha. Haikyuu is really good. Isn't that the poem? The 5-letter, 3-letter poem? Haikyuu? Is that what it's about? Numan Raisin? That's haiku? Okay. It's not haiku. Hey, I'm uncultured. I don't know. Okay. How many people are watching on YouTube? One person? 4 people are watching. Hi, 4 people watching. Say hi at least. Gori says hi. Zen, salam alaikum. How are you? We're starting in a bit. I'm just catching my breath, if it's okay. I'm just a little too excited, I think. Haikyuu is a volleyball? Oh, I think... Isn't that the really weird one? Haikyuu? Haikyuu. If something weird shows up, I'm going to hit someone. Oh, okay, it's not the weird one. Okay. We'll start as soon as we're done with the syllabus, I feel. Maybe even sooner if a lot of people request it. We should probably start studying. I agree. Let's start. Party pooper. But okay, let's start. Okay. We're going to do something this time around. I'm actually out of breath. I don't know why. Not that I was running around or anything. I was just sitting. I feel out of breath. Okay, stop talking about anime. It's distracting me. Let's start. Welcome, guys. Let's start. Let's begin. Okay. So we know some things about a lot of hydrocarbons. Well, they're functional groups per se, and not too much. No. alkanes, then you have alkenes, then you have alcohols, then you have carboxylic acids, carboxylic acids, and what an alkane is, forgive me, I'm not in this slide, I'm not going to draw any of the hydrogens because otherwise I'll need to go to a hospital. This is what an alkane looks like. This is what an alkene looks like, right? An example. It could go on. This is an example of an alcohol. This is an example of a carboxylic acid. मैंने oxygen, I'm putting it नीचे, below the double bonded oxygen, right? Does that make sense? So we've seen this before, we know it, we love it. These are our major 4 organic compounds which we cover, right? Now, one thing I want to focus on is, do you guys agree, majorly the part of each molecule is an alkane, kind of, you can argue that. Isn't that like, isn't all of this part just alkanes? Technically, like, I'm not saying it is, be careful, right? I'm trying to highlight, they're similar. Can I argue that? Why does it look lighter? What do you mean? What looks lighter? Something's wrong with the video? Sir, ये 9th class है ना? I wasn't counting. 4 for organic, I think, then this is the second alkene, this is the 6th class. Pen is really faint, I'll change the pen. I zoomed in, I think, oh, it didn't zoom in. Did it zoom in when I zoomed in? Yeah, it did, no? I'll change the pen right now, but because I've written it. Does this make sense? ठीक है, okay. I'm arguing that most of the molecule is similar to, let's say, an alkane, right? Can I make that argument? I'm not saying it is. Oh, I forgot to draw the OH for alcohol. Yes? Nim, how are you? You're excited? But no one's agreeing with me. Like, can we, do I have to tell everyone to agree with me? I look for feedback, right? I'm that guy. I'm that person. Like, okay, just give it to me. Like, just let me hear it. Come on. Agree, or don't agree. Haya said it twice, so, like, I don't know. Come on. Agree or disagree? Agree to disagree. Hurry up. Let's hear some responses from people. People on YouTube, are you gonna, you're in our class, at least participate. Say hi, say, agree or disagree to the things I'm talking about. I know there's a bit of lag, so I ignore you guys a lot, but I try to answer the questions, so, I'm asking a question here, guys. Accept the functional group. Okay, right. So if we understand how a molecule like this works, we can probably apply similar, so they'll share some sort of properties, right? And they do. They share physical properties with each other. So if you understand an alkane's properties, physical properties, you can understand an alkene's physical properties, you can understand an alcohol's physical, so on and so forth. I won't continue. Okay. So we'll study alkane's physical properties in a bit detail, and we'll apply it to every other compound. And if something else has a different physical property, we'll highlight it differently, separately. But to understand alkanes, do you guys understand? Like, alkanes would be the base of organic chemistry, then you put functional groups on top of it to, okay, people are agreeing. My pals, Nim, my pals, Raji. I don't have a time, Usman. We haven't put that on our schedule yet. We'll do as soon as our syllabus is done, or maybe start earlier if people are requesting it. But we're kind of overworked right now. Maybe I'll be free in a few weeks, and maybe we can start doing more O-levels. Okay. Well, some people and not all. Yeah, I'm kind of like, I'm not hearing a lot of people say anything. Ayla said it, Rame said it, Miral. Yeah. So, you know, Rida, are you going to say anything eventually? Noman, hello, how are you? You know, Anan, I don't know if you said anything, but I'd like to hear people talk more. Okay? Just letting you guys know. No need to spam it right now, but please. Okay? Let's move on. So we're going to study about alkanes, and here's something about alkanes. We'll start and we'll use a less faint pen, and we'll first write alkanes on top. Okay. And we're going to discuss their melting point, if that's okay with you guys. CH4, that's our first alkane. Our second alkane, what is it? C2H6. Then we have C3H8, C4H thus, C5H12. Actually, I don't want to go that far. Let's keep it here. Hello, Masam. Masam, didn't you say hello? Didn't we say hello already? Or are you referring to, did you? I did. Oh, you already talked. I'm just asking everyone else to. I hate this line that shows up on the side. Okay, it annoys me to no end. Anyway, so we're talking about what again? We're talking about melting points. And let me write the trends. So I'm going to write the melting point for all of these. Melting point for all of these in degrees Celsius, right? And what I know is, I'm just copying it from somewhere. I don't know these. You're not supposed to know these. We're just looking at a trend. Minus 164 degrees Celsius, minus 87 degrees Celsius, minus 42 degrees Celsius, minus 0.5 degrees Celsius. Wow. Wow. Combustion reaction. Wow. That's hilarious, Haya. You were studying? Oh, we should do electrochemical cells. It's pretty, I can see why you think it's boring. It is boring. I don't hate it. I don't find it boring. I find it interesting. But I am not surprised if people find it boring. But can we talk about this? We're talking about this. Please don't get distracted, guys. Or maybe we can take a small break and, we don't need to learn the melting points. We're looking at a trend over here. So what's the trend over here? What's happening to the melting point? What is happening to the melting point, guys? If I go down this list, what's happening to my melting point? Can I say it increases as the number of carbon increases? As the molecule is getting bigger, it's getting not decreasing. That's a good point. It's actually increasing. The values are getting smaller, but they're negative numbers. So whenever you're confused about this, draw the number line, right? Let's actually draw the number line over here. Who asked this? The melting point is increasing, not decreasing. Messam asked this. Messam, this is the number line, right? You have 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And you have 1, 2, 3, 4, 5. And you have -1, -2, -3, -4, -5, right? The idea is that if you're going from 0 to 2, is your number increasing? Are you adding? Is it increasing? Yes or no? Yes? If you go from 3 to 5 or 2 to 5, are you increasing? Is the number increasing? right? So anytime you go from left to right, you're increasing. So as long as I'm going from a point towards the right, I'm increasing, right? So if I'm at -4 and I go to -2, am I increasing or decreasing my number? I'm increasing it. Does that make sense? Because from -4 you have to add 2 to come to here. Much like from 2 to going to 4, you have to add 2 to it. Does that make sense? Alright, does that make sense? That's the idea, that's the number line, kids. How many of you want me to start maths now? Okay, let's come back here. ठीक है. Does this make sense? Melting point is increasing as I go down. So after butane is going to be pentene, which is going to be, I think, a liquid at room temperature. Make sense? Brilliant. My AC is barely working. Okay, let's not get distracted. Can someone try to explain why it's increasing? Someone tell me. Why this increase? Why is it increasing? Think about it. I'm going to give everyone a minute. Think about it for 1 minute, no talkie, then write your answer in 10 words or so. People on YouTube, I'm expecting an answer. Tell me why. No, more carbon is something already I said, but if the molecule is getting bigger, why is the boiling point increasing? My question is, why is the boiling point increasing if there are more carbons or if the molecule is getting larger? This has more bond. Okay, what sort of bonds? MR increases. Okay. More energy needed to break the bonds. Okay. Okay. Think about it. Give me a good answer. Because strong bonds of carbon increases van der Waals forces increases MR. Miral kind of knows it. ठीक है. More energy to break bonds. ठीक है. Now the molecule is increasing in size. So a lot of people say the MR is increasing, so it's getting heavier. So it's harder to boil or something. And that's completely incorrect. It has nothing to do with its weight, right? So not to undermine anyone, it's just wrong, right? Don't think like that. What causes something to be a liquid or a gas are the intermolecular forces that you know from states of matter, right? You guys recall that? Something is a liquid because they have strong enough forces and prevent it from flying away, right? These forces are called intermolecular forces or van der Waals forces. Now, why are van der Waals forces increasing? I'll try explaining that. That's my job now. But so far you increase, for some reason the van der Waals are increasing right now. Right? You guys agree to that? The boiling point is increasing because van der Waals forces are increasing. You guys understand that? Has nothing to do with the MR, has nothing to do with the number of carbon increases? No, Arisha. Number of carbons why are van der Waals increasing? Number of carbons, is that why? Kind of. That's not the direct linkage. That's a correlation, that's a result, but not the exact cause why van der Waals are increasing or why they're stronger. No, that's a good observation and you'll do that, you'll make that link, but that's not the exact reason why, right? Exact reason. I'll talk about the exact reason why. ठीक है. Van der Waals are increasing as the number of carbon increases. That's the summary you'll get out of this. But I'll also talk about why they're increasing. But if everyone's understood that boiling point has to do only with van der Waals forces, if everyone's understood that, then we'll move on to the next part. All clear so far? Spam yes if you guys agree. People on YouTube, spam yes if you agree. We're at 6:20. Lionel is already on Zoom as well. What is this sorcery? Okay, people get it. Now I'm gonna draw the first 4 alkanes and try to show you. Okay, I'll draw it over here. So before I draw it, let me talk about Scotch tape. Now, when I was a kid, I found something very surprising. Now, okay, this is a silly example. Don't add me, right? Don't add me. But this is a silly example. But let me give you like a piece of something to relate to. If you have a small piece of Scotch tape, right, like that, and you stick it to, let's say, a table. I have a table in front of me. You can't see it, but obviously I have a table in front of me, right? So if you stick it on the table and you stick it, it's stuck, right? And you remove it. And you're like, oh, this is very easy to remove. It's probably not good Scotch tape, right? And you're like, okay, something, whatever. Then you do is you take a longer piece of Scotch tape and you stick it to the table, nice and flat, zip. You know, you press it nice and flat and it sticks. Okay. And once you do that, and when you try to remove it later, it's just harder to remove. It's hard to remove that Scotch tape sometimes. Not all the time, but sometimes it's all of a sudden, you try to remove it, it's just so much tedious. You're like removing it, nikal hi nahi raha yaar. You know, you're doing it, especially if there's a Scotch tape, you know, also wider as well. It's not that there's more or stronger glue on it, it's just wider and bigger. Obviously this is longer because you took more tape, but if it's wider, it's also more difficult. And you always think it's a better quality Scotch tape in your head, but no one's actually paid attention to it. I'm the only nerd that did it. Do you guys, have you guys ever felt this difference? In a small piece of Scotch tape, it's always easier to remove. Yes, Miral says yes, some people agree. Okay, Mesam agrees. Yeah, actually, right? Like, yeah, that's the kind of a response I'm thinking about. Because you don't think about it until like, yeah, now that you say it, it's true. It happens, right? And that's something similar to what's happening to the molecules. So keep that in mind. Keep that in mind. I have CH4, I have C2H क्या है? 6, I have C3H8, I have C4H10. I'm going to try my best and draw the molecules for each of these cases. Let me try drawing that. Okay. Now what I'll do is I'll just draw the carbon atoms and not focus on the hydrogens, or like just, you know, so it's easy for me. So instead of drawing something like a carbon atom with hydrogen sticking out of it, it's going to get difficult by the time I reach over here. I'll just draw just the carbon atoms like that. So do you guys agree? If I could just only see the carbon, I could filter out the hydrogen atoms, I would only see these. Miral thinks it's a good example. What's a good example, Miral? Also spam yes if you guys understand these are carbons of methane. The tape one, right? Miral knows where this is going. So Miral goes like, that's a brilliant example. I feel it's a brilliant example because once you understand the tape example and apply it over here, you're like, man, molecules are just nothing. They're just physical things attracting each other. And that's the idea with the tape example. Okay. And there's attraction between it. What is the attraction called? Van der Waals forces. They're attracting each other and it's a gas. And yeah. Okay. Now here's my ethane molecule. Again, I'm only focusing on the carbons. I'm not drawing the hydrogens, but I'm drawing the covalent bonds between hydrogens, right? So this would actually look like hydrogen coming out on each carbon, but I'm only drawing the carbons because otherwise it's going to look really ugly. This is what it looks like. Okay, really good example. I like the way you guys think because I feel this is a really good example as well. I'm enjoying the fact that you guys are enjoying my example. Sorry, Ramesh, sorry to hear that, but we're still talking about it. The temperature, the melting point is increasing because van der Waals force is increasing. Now, why are van der Waals forces stronger is I'm arguing here. Okay. But Ramesh, you'll have to focus a bit. I don't want to repeat myself because we spent so much time on it. I think I'll ask you to watch the video again because that's an option. But you can always ask again in the next class. Okay, but I'm going to move on. Okay. Now, do you guys recall how a molecule looks like a hydrocarbon? It starts going zigzag, right? I'm going to do that. I'm going to start drawing them ziggity-zag. Why do I do these things? This is what propane looks like, right? They're all ziggity-zag. Right? What else can I do? Yeah. I'm just drawing it untidily. It's a little more organized, by the way. You missed the Scotch tape thing, yeah. So we're comparing it to Scotch tape, and I think I'll bring the Scotch tape back. Something, my nose is bothering me. Okay, okay now. I'm too tired to draw this, but so I'll draw it in a neat pattern. And yeah, attraction, look at that. Sir, a good work? Lionel is everywhere. He's Batman. I think I can do a really good Batman impression. I'm Batman. No. I have to watch the movie again, I guess. Okay. Does this make sense? Do you guys see where this is going? Do you, look at it. There are more forces just by drawing it out. There are more forces. As the surface area of the molecule is increasing, there are more and more attraction. The attraction intensity is not increasing, but the surface area is. Right? It's getting larger. So the longer tape, much like how it's harder, the glue hasn't changed in this tape compared to a smaller tape. It's the same freaking glue. And if you're confused about why a longer piece of tape is, harder to separate, think about this. It's the same reason if you're hanging from a bar, if you're really into physics, if you're hanging from a bar with one hand, all the forces is one hand. Right? That's where it's concentrated. But as soon as you double your area, surface area, by holding it with two hands, your fingers feel a lot more, like you can hold on for longer because it doesn't hurt. It doesn't feel like it's ripping your fingers as much because your force has been divided into that surface area, right? So that's with the glue. Kind of like the similar example. In a bigger tape, technically you're also using a lot more glue, aren't you? It's the same glue, but there's a lot more of it. Of course, it's going to be more difficult to remove the second one. Van der Waals forces will depend on the surface area, right? Or not will exactly, that's going to come in a bit. The surface area bit is going to come in. But the larger the molecule, obviously, you can just say larger molecule, and that makes it. But I'm trying to be as detailed as possible. Because if you understand this, this is going to carry you till A2 chemistry. I don't know anything after A2 chemistry, so, maybe it'll carry you for the rest of your life. But does this make sense? Do you guys understand this? The larger the molecule, the more the attraction. So if I come back here and if I ask you, what do you think is the boiling point of C8H18? What are you going to say? Or if I make it simple, is it going to be higher or lower than butane? What are you guys going to say? Higher, 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 higher. Not because there's a trend and increasing. Don't ratify it. Understand why it's higher. Right? You guys get this? Spam yes, and I give you a question, and you guys figure it out. I'm Abul, not Abdul. And I'm not the son of Sir Bilal. I'm the son of my dad. Don't teach how faces changes? I'm trying to be Sir Bilal. I don't know. What's don't teach how faces change? Maybe what? What are you guys talking about? People get it? Okay. Here's my question to you guys, and don't quote me a book example. Try to understand it and try explaining. I have two molecules in front of me. One is the butane you saw. One is an isomer of butane. Which of these two will have a higher boiling point, and which of them will have a smaller or lower boiling point? Not smaller. That's incorrect. What are you guys saying? I'm going to give you guys a minute. Which do you think will have a lower boiling point? He was thonking that Sir Bilal has changed. Yeah. I look way different if I take off my glasses, right? I age 10 years, like I de-age 10 years, and my hair looks longer when I don't know. People say it would be the same, but will it? Think surface area, guys. Think. If you guys get the tape example, if this was two pieces of tape, how would this tape be different? It is an isomer, yes. They're both C4H10. Think Scotch tape. Tell me. Explain it to me like they were Scotch tapes. Explain it to me like they were one of your Scotch tape girls. Or I was just trying to make a reference. The first one from the left will have what? I say take a minute, form an answer, and then tell it to me. People on YouTube, isomer has a lower boiling point, says someone. Actually, they're both isomers of each other. It's incorrect to say one is the isomer of the other. They're both isomers. It's kind of like they're both siblings, I guess. It's not like one is the sibling of the other. Aisa nahi hota. They're both isomers of each other. They're both isotopes of each other, not these like chlorine. So you don't say this is an isomer, Like you can't say this is it's not wrong to say that, but you don't see it like the isomer over here. They're both isomers of each other. They're both structurally different, but have the same molecular formula. Does that make sense? Zen, Zoe, the younger sibling? What? But no one's talking about Scotch tapes. So people really praised my example, but no one say me, Scotch tape. How would the Scotch tape in this example be different? If this is a straight Scotch tape I stuck to a table, how would this be different? Can you guys think like that? And visualize it? You like the one I drew later? You like this one? I like it too. I don't know if you guys have ever noticed this. Sometimes you take a piece of Scotch tape out, right? And it's complete, you know, and you stick it somewhere completely neatly and there's no gaps, you know, इस तरह लाइनें बन जाती हैं on Scotch tape. Sometimes folds आ जाते हैं बीच में, right? ऐसा नहीं हुआ, right? Now, you took out another Scotch tape but while you took it out, हवा वगैरह चली and it kind of, right? And it got gichar-michar, right? आपस में. And this is what happened to the Scotch tape. It's like attached to the table, but it has these, you know, how do I draw that? Lol. You know, it's not uniform. It has those lines in the middle, like folds aa gaye beech mein, right? And that's true for this guy as well. Because if you notice, it's not in a straight chain. It's branched. So how does that relate? But let's stick to the Scotch tape. Which of the two is easier to pull out, easier to remove? Do you guys agree? Over here, let's say, over here, 100% of the Scotch tape technically is being utilized, where let's say 80% of the Scotch tape is being utilized because of these folds. They're sticking to each other, not sticking to the table. So they're not adding to the force of the glue. Right? You guys understand that? Right? So if I had another molecule of these two, look what's happening to the two of them. Right? And over here, look how long these gaps are. Look how much longer they are compared to these lines. Yahan pe to it got as close as it could, but the other lines are so much longer. It's further away. Because it's further away, can I also argue they're weaker? They're way weaker? These forces are weaker because they're further away, much like how magnets, the closer you bring them, they become very strong. But the further they are, the weaker they feel. And your force of attraction drastically changes as the distance changes. If they're very close, it's very strong. And if it's like, it doesn't mean like if you double the distance, would the force half down? No, it drops by a lot more. There's a huge drop, right? So even though they're away, this force is much lower. And this has more force. And not only that, it has more surface area in contact with the other guy. यहाँ पे surface area भी इतना नहीं है. Even though the forces weren't decreasing, you know, ऐसे तो attract नहीं करेगा. So even the surface area is less. This molecule cannot get any closer to the other molecule. Physics is what's happening right now. So what? What is the conclusion? This will have a higher boiling point. Am I correct in saying that? More forces, more tougher to separate, right? A higher boiling point compared to its isomer, right? Higher boiling point compared to lower boiling point. Does that make sense to you guys? I missed out. Sir Bilal, please enter politics. I'm not Sir Bilal here. Wasif, don't say stuff like methyl groups are attached. Okay. People get it? Yes, absolutely. Here's a general statement which people are taught and made to memorize. But, you know, if after all of that you guys find it difficult, branched isomers will always have a lower boiling point / melting point, right, compared to, actually I said melting point earlier, I meant boiling point earlier, right, compared to, let me go back and fix it, compared to their straight chained counterparts. Does that make sense? You'll have MCQs related to this. They'll show you isomers, they'll ask you, hey, which of these do you think has a higher boiling point? Oh, my first dislike. Mesam, is it you? Day ruined. Well, day's over anyway, which is okay. So at least I didn't get it early on. Okay, yeah, it wasn't you. Okay. Does this statement make sense to everyone? Spam, yes. Spam, Crystal, if you guys agree. Spam, Crystal. It's always you, Mesam. Last few times you said you were doing it. Crystal. No, okay, one person doesn't spam it. No, stop it. No, I don't like that spamming. Just type in Crystal once. Do not spam. I don't like that. Conversations go up. If someone says something urgent, I can't see it. Don't do that, please. Okay. Don't spam. I don't mean spam, like say it once. Okay. I want all of you to spam together, not one guy. Okay. Okay, I'll go back. I made a mistake. I didn't mean melting point. Well, I didn't mean melting point either. I wrote down boiling points because from a gas, it's turning into a liquid over here. So that's the boiling point. Okay. But same thing, right? We're not trying to memorize the boiling points. We're trying to understand the trend. I'm going back. Copy the statement. I think now we have trolls. I think I should just turn it off, the dislike thing. If I see it, it just shows up in my screen, like it makes an animation and like big thumbs up or big thumbs down goes down. And when I see that, it just ruins my day. I should disable that and, you know. Anyway. Yeah, I'll disable it. Lamau. Okay, do you guys understand this? I wanted to do a lot more in alkanes, but we just did this. But I think people understood what I'm trying to say really well. Appreciate how physical this is, right? So Bilal is a shoot person. Saad, I don't know what you're doing. I didn't read the history, but I don't know. What are you saying? What are you saying, man? What are you saying? You guys get it? Okay. Let's talk more about alkanes. Appreciate this part. We'll do questions in a bit, or like tomorrow. I don't think we have time. Okay. Okay. I think that's it. There's another thing I want to talk about, but it'll take longer than 5 minutes, of which we have, because Sir Bilal definitely has a class today. But let me say this thing. You were told this yesterday, I know, but I want to... What does the word saturated mean? Three politician qualities found. What are they, Saad? List them down, 1, 2, 3. Yes. Saturated means something that's full of something. You guys know this? Spam, yes, if you guys know this, I don't have to talk about it. You guys know what saturated means? Okay. If I say a saturated alkane, it means what? It's not Abdul, it's Abul, it's ABUL. They have single bonds. There's no double bond, essentially. There's no carbon-carbon double bond. ठीक है. There's no carbon-carbon double bond. That's what you mean? That's what you mean? Okay. I'm really not enjoying what Saad is saying. I'm not really enjoying what Saad's saying. But who cares? Okay, let's come back. ठीक है, you guys know this? Okay. Okay, let's talk about the last thing. Okay, acha, there was one important thing. One important thing I wanted to talk about. Okay, you guys understand physical properties of alkanes. Their melting point, their boiling point. ठीक है. Can you imagine living on a planet where the atmosphere was, let's say, hydrochloric acid gas? Right? Now, on our planet, yeah, I think Saad's just really annoying me. And if he's annoying other people, I gotta kick him out. It's just that I have to, he just wasted 2 minutes of my life because I have to log on to YouTube and kick him out. Thank you, Saad. I hope you realize how annoying you are right now and how many people's times you're wasting. Okay, that's timer doesn't help me. Can I just add height, put? I want to remove. I'm just reporting him at this point. I can't. Harassment or bullying? Yeah, that's a little intense. Okay, never mind. 300 minutes, that should be done with class. Okay, I close the window. Yeah, sorry, if someone bothers you, let me know because I wasn't paying attention to the comments. ठीक है, you're welcome, Zain. ठीक है. Yeah, ACL does not sound good. Now, on our planet over here on Earth, metals are considered like something really strong and really useful. You make buildings and airplanes out of it, right? On Earth, they're strong. On Earth, metals are like really good things because they're not reactive, they're very light, they can carry a lot of weight, they conduct electricity, very useful things. On planet X, they'd be dangerous because acids readily react with metals, right? Now, if there was a metal over here, it would literally, how wood burns over here, metals would catch fire in a place like, I guess you need some water as well. But yeah, metals would catch, not fire, but it would be very close to a fire sort of reaction. On that planet, they would burn metal like how we burn wood. Does that make sense to you guys? Spam yes if that makes sense to you. Sounds silly, but if you think about it, that's true, right? That makes sense. And that's the issue with oxygen. Oxygen is a very dangerous gas. Honestly, it's just that people like you and me are immune to oxygen. Well, people and life is immune to oxygen and is only benefited by oxygen. Oxygen is a very dangerous gas. It's very reactive, highly reactive. That's why so many things burn. No. Burning is a non-chemistry way of looking at it. It's a blue-collar way of looking at it. The layman says things burn a lot. A chemist says so many things react with oxygen violently. That's what they say, right? That's what you have to start thinking like. It's not that petrol is flammable. It's just that petrol is, like a victim to oxygen. Do you guys understand what I'm trying to say? Yeah? And the idea is alkanes are unreactive. Because they survived under the surface of our planet for millions of years. They're literally dinosaurs, alkanes. They're petrol, right? Alkanes is petrol. Oxygen should be ashamed of itself. Alkanes are unreactive. And that's a weird thing. It's like you're having like a midlife crisis right now. But alkanes are also stuff like petrol. CH4, which is an alkane, is natural gas which we burn. How could you call natural gas unreactive and petrol unreactive? It's insanely reactive. But it is unreactive. Aside from oxygen, it reacts with nothing. Absolutely nothing, aside from like one or two other things. But then again, metals are more reactive than organic compounds. Metals are far more reactive than, because metals, when you find them, they're almost never pure. They're iron oxide, that's how you extract them. Petrol, when you extract it, it's still petrol, it's just impure, mixed. It's a mixture. You separate it by fractional distillation. You don't make petrol, right? Does that make sense? It's only at the surface where they can burn and blah, 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 blah. Do you guys appreciate this point? Spam that emoticon if you guys appreciate this point. But I'm telling you all of these things not for you to write in the exam, but for you to understand. Note that. When someone says alkanes are unreactive or petrol is unreactive, that's what they're trying to mean. It's only us. We're exposed to all this oxygen. Oxygen's the culprit, right? Because everything burns in oxygen. If there's no oxygen, nothing burns. ठीक है? I'm exceeding the time. ठीक है? You guys appreciate this part? Aside from combustion, alkanes are unreactive. And that's where the functional group comes in. Because the functional group allows it to undergo other chemical reactions which an alkane will not. Arisha, I hope you're appreciating this point because you were the one, you're like, functional groups, like the Jackie Chan emoji, right? Do you appreciate this group, Arisha? This, what I'm trying to say? Right? Why you know alkane? Why you functional group? You're welcome. You're welcome. I hope you understand this. Okay. Alkenes undergo one chemical reaction, which we care about. They probably do one or two others, but to us, just imagine it's only one, right? Alkanes undergo substitution reaction. Only one. How many? Only one. Aside from combustion, of course. Alkanes undergo substitution reaction. And we'll do that tomorrow, if that's okay. ठीक है? I don't teach at any colleges right now. I teach at a school, Waals. This is what I teach. Do you guys appreciate my point? Do you guys understand that? Did you guys enjoy the class? I know it was very slow, but I think the message went across 10 times better than in any other class. Do you guys agree? I'm sorry for taking so much time in alkanes, but if you understand these little things, we won't take this much time in past papers, and you guys will fly through past papers. Okay? And it was also fun. I'm just staring down at that one dislike. Why am I like this? Okay. Okay, I'm gonna end it here. So Bilal is probably about to start his other class. Thank you for coming. Thank you for enjoying. Thank you for appreciating my tape example. Who knew that, the tape example is probably like, Mom, look at me. Are you happy now? Kya hua? I don't know what Saad's saying. Let's just ignore it. Bye-bye. I hope you... Bye-bye, guys. Say bye-bye and drop out. Bye, guys. Bye, YouTube. Take care. Allah Hafiz. Sayonara. My rejoinder to my criticizers. What? Bye-bye, guys. Take care.